What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of the square root of 36 all over 6 minus the square root of 35. Well, our first step will be for us to rationalize the denominator. So we have the square root of 36 all over 6 minus the square root of 35. So rationalizing, we're going to be multiplying the denominator by 6. Here we have minus, then here we're going to be having plus the square root of 35. We're also going to be multiplying the numerator the same way. 6 plus the square root of 35. Well, this expression can also be written as the square root of 36 times 6 plus root 35 all over the denominator 6 minus the square root of 35 times 6 plus the square root of 35. Now let's multiply. So we have the square root of 36 times 6 is 216 plus 36 times the square root of 35 is 36 root 35 all over. Now notice that the denominator is of the form of difference of two squares, which is of, for example, x minus y times x plus y. So this is the form of difference of two squares, which is written as x squared minus y squared. Now let's write this denominator like this. So we have 6 squared minus the square root of 35 squared. So this gives us the square root of 216 plus 36 root 35 all over. Now 6 squared is 36 minus. Now notice that this square can cancel off the square root, leaving behind 35. So this results to 216 plus 36 root 35 all over. Now 36 minus 35 is 1. And 216 plus 36 root 35 divided by 1 gives 216 plus 36 root 35. Our next step will be for us to write this expression inside of this square root in the form of a perfect square, such that it looks like a plus b squared. Remember that a plus b squared is expanded as a squared plus b squared plus 2ab. Now let's write this expression in this form. So we have the square root of, this is 216 plus, since I have 2ab here, I'm going to be extracting the 2 from this 36. So 2 times 18 gives 36. So I've been able to extract 2 from 36. So 2 times 18 is 36 times the square root of 35. Our next step will be for us to write this 18 inside of this square root. And for 18 to go inside of this square root, I'm going to be writing it as the square root of 216 plus 2. 18 is same as the square root of 18 squared, because square roots can cancel square, leaving 18. So this expression and this 18 are the same. Then times the square root of 35. Our next step will be for us to write a common square root for 18 squared and 35. So this becomes the square root of 216 plus 2 times the square root of, remember, I'm writing a common square root. 18 squared is same as 18 times 18. And then 35 is same as 7 times 5. Let's move on to the next slide. So this simplifies into the square root of 216 plus 2. Now this becomes the square root of 18 times 7 is 126 times 18 times 5 is 90. So this becomes the square root of 216 plus 2. Now let's separate these two expressions here. So this can be written as the square root of 126 times the square root of 90. Now notice that the addition of 126 and 90 gives 216. So this expression 216 can be written as the sum of 126 and 90 plus 2 times the square root of 126 times the square root of 90. Now remember that our aim is to write it in this form, a plus b squared, in form of a perfect square, which is expressed as a squared plus b squared plus 2ab. So now we're going to be writing 126 and 90 in such a way that they have a square. So this expression now becomes the square root of, now 126 is same as the square root of 126 squared. The reason is because the square can cancel off the square root, leaving just 126 to be the same as this. We're going to be doing the same thing to the 90, so plus the square root of 90 squared plus 2 times root 126 times root 90. Now notice that what we have inside of this radical now resembles what we have here, in such a way that a is in the form of the square root of 126 and b is in the form of the square root of 90 when we compare. So now let's write this expression like this. So we have the square root of a plus b. Our a is the square root of 126 plus b. B is the square root of 90, and we're going to be squaring it square. Now notice that this square can cancel off the square root, so that we have the square root of 126 plus the square root of 90. Let's continue on the next slide. Our next step will be for us to decompose 126 into two factors, one of which is going to be a perfect square. So we have the square root of 126 is same as 9 times 14. 9 is the perfect square. Plus, we're going to be doing the same thing here. We're going to decompose this into two factors, one of which is the perfect square. So we have the square root of 9 is a perfect square times 10, which gives 90. So let's separate this. So this is the square root of 9 times the square root of 14 plus this is the square root of 9 times the square root of 10. So the square root of 9 is actually 3 times 14 times the square root of 14. So we have 3 root 14 plus the square root of 9 is 3 times the square root of 10. That's 3 root 10. Now notice that 3 is common. So we can factor out 3 so that we have 3 root 14 divided by 3. I'm going to be having the square root of 14 plus 3 root 10 divided by 3. I'm going to be having the square root of 10. And this becomes our final answer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.